Okay, so let's go ahead and get started. So today we're going to talk a little bit about brain functions and the endocannabinoid system. I apologize, I have to look down occasionally, but this is somewhat new material that you're getting presented. Some of this is kind of old material, but a little bit deeper dive on that older material. So real quick, I just want to talk you through kind of our model at New Pharma and, why we think this stuff is so important, but why it's so hopeful and optimistic, everything that we know here within New Pharma. So in our minds right now, we're all kind of driving these beat up hoopties, right? And that's what our physicality is. We're breaking down. We have all these dysregulations that we don't understand. We kind of don't understand why our vehicles are breaking in all these different ways, right? But as we begin to understand our master regulatory system, the thing that really runs our vehicles and manages our vehicles and how they, perform and what optimizes our vehicles, as we begin to understand this system, we're going to be driving a lot better vehicle in the very near future. And hopefully this is, 2021 and not, 2090. We're getting there. We're waking up. We're starting to see this stuff, which is great. The charms are broken, so to speak. Let's break the charm, shall we? Let's break the charm around this information. So anyway, but let's talk about how our bodies regulate a little bit, because I think that's really important information. Now, if you guys are like me, back in high school, we were taught that our bodies regulated through the use of hormones. Well, that frankly makes no sense, and it's kind of naive and basic, all right? Hormones regulate our organs for the most part. You need to get hungry, that's a hormone. You need to feel full, that's a hormone. You need to manage your heart, that's a hormone. You need to upregulate your sexuality, that's a hormone, right? So hormones help us regulate our organs, but what regulates hormones? Well, your pituitary regulates hormones, but your endocannabinoid system regulates your pituitary. So again, that's kind of old thinking. So real quick, 3 points about the endocannabinoid system. Again, I say this every time. If you don't remember anything else about what I say, remember these 3 points. Point 1, it's really old. We developed it in something called a sea squirt. We were a mouth, a stomach, an exoskeleton. We had a little tail. We had an endocannabinoid system. We had a few other things, which we'll talk about later. But we were very basic. From that guy, we diverged from insects. So insects went one way, everything else on the planet went the other. For the most part, everything else on the planet has an endocannabinoid system. So this system, very old, very ancient, very common, should tell us all how important it is. Point 2 about it, looking to be our master regulatory system, as I just mentioned. What does that mean? What does that look like? Satisfy yourself to the amount of research, NIH.gov. There's plenty of research out there. But what does it mean? What does this mean in reality, that it's our master regulatory system? Well, it means we work like our car. And it means we're driving dang beat up hoopties until we can figure this out. But it means that we work like our car. And again, in our vehicle, we understand that there's a computer that's always watching every system in our vehicle, what the engine's doing, what the tires are doing, what the windshield wiper fluid is doing, what everything is doing in that vehicle. And the computer is always trying to balance that vehicle to perfect flow, perfect balance, perfect homeostasis, right? Perfect function. Well, guess what? We work very similar. That's a very logical and elegant way to work, right? We have a hypothalamus hippocampus, and again, it's always watching every single system in our body, trying to balance it to perfect homeostasis, perfect balance, so we get the most out of our vehicle, out of our function, right? Again, if that conflicts with your spirituality, I would argue we're two things. Again, we're a vehicle that works under this master regulatory system, and we're an incarnated spirit that sort of drives that vehicle. Choose your paradigm. But that's kind of the way it's looking to me. All right, so point 3, how do we run this system, right? So it manages everything inside of us. It's managing our blood pressure. It's managing how many times I blink my eyes, how many times my heart beats, how my cholesterol level is managed, how my blood pressure is managed. all of these things it's managing right now, in addition to a jillion other functions inside of me. So how does that work? How does that work? Well, the endocannabinoid system runs on chemical mediators, right? So we all understand that we have central nervous system mediators and we have hormone mediators. We have all these chemical mediators that kind of work in this elegant bouquet that allows us to run and manage our body. Well, it's, again, these endocannabinoid resources sit way above everything else, but they come from natural places, natural resources. So again, I'm going to talk more about dopamine and serotonin in a second, but a lot of us know about dopamine and serotonin. So I use this all the time to illustrate this point, and we'll kind of come back to this point a little bit later on, but you can kind of read about a dopamine deficiency or a serotonin deficiency. And again, the endocannabinoid system sits above, it's actually managing, and that's what we'll talk about, the dopamine and serotonin. But without dopamine and serotonin, you're a depressed Parkinson's patient, right? So give me some more, give me some more. I want all the dopamine and serotonin I can get. How does that happen? That happens by precursors, okay? So in particular, something called L-tryptophan and L-tyrosine. So if I put you in a box and I said no L-tryptophan and no L-tyrosine for you, you would not be able to build dopamine and serotonin. In short order, you're a depressed Parkinson's patient. You can't think, you can't generate mood, you have no cognition, you have sleepy brain fog, and you're depressed like you've never been depressed before. I give you and sadly, that's kind of the state that a lot of Parkinson's patients are in, but I give you a L-tryptophan and L-tyrosine biscuit, and guess what? You take those molecules and you break them down into dopamine and serotonin, and now you come right back online. Now you're functional. So point 3 about the endocannabinoid system, it's driven by natural resources, omega-3 and omega-6 fatty acids. We have to have them in perfect balance or within range, 1 to 4, let's say, somewhere in there. And if we have that, then we're very healthy. If we don't, then we break, and we break just like we'd break if we broke your endocannabinoid system. So again, here at New Pharma, within True Medics, our CBD brand, we would argue that we're all driving malnourished, let's put it that way, vehicles, right? So we're all driving these kind of hoopties, and they're hoopties not because of our fault, just because we don't really understand the resources that we need to give them to fully function and to be our wonderful car of the future, right? Okay, so let's talk a little bit about how our brains work. And there's a lot of commonality between dopamine and serotonin. So you're going to hear a lot of commonality, but I want to really kind of dive into this. And the reason that I want to dive into this, in some of the other presentations, we talk about master regulatory system eyes versus PDR eyes versus, you know, how is it today in science, and how will it be, you know, in the future as physicians begin to understand all this science and kind of begin to understand about the endocannabinoid system. So right now, if you have a mood disorder, if you have PTSD, if you have anxiety, if you have depression, any of those type things, or maybe you're just feeling a little blue, you know, and you go to the doctor, that physician is going to judge you by what you tell them. Okay. And again, if you say, gosh, I'm a little depressed, doc, or, you know, I'm anxious, which I am, but, you know, I'm anxious, or, you know, I, you know, hear loud noises and I, you know, kind of get fight or flight, and then I get depressed as hell. Right. So he's going to look at you, not like you have some kind of dysregulation in your body, certainly not like you're malnourished, right? Which is really the case. But he's going to look at you like you're broken, you're busted. And he's going, you ever get that? Feel that judgment? Again, you are being judged, and they're kind of viewing you as you're broken, you're malfunctioning, you're broken. That's really, now certainly we can break, you know, but it's usually traumatic, you know, or genetic. So we know it, you know, long when we're born or when the trauma happens. So we can break, but it's genetic or traumatic. It's not regulatory. If we're breaking in our regulatory, or appearing to break in our regulatory, that's regulation. That can be fixed by changing the regulation. That, by virtue of definition, that's what regulation is. If something is dysregulated, it can be re-regulated. It would appear broken if it was dysregulated, right? So there our argument at New Pharma and within the TrueMedics brand is that most of the things that we view as diseases are really just dysregulations. They're things that we don't understand yet that can be fixed with safe, frankly, safe supplements. Safe resources can be provided to the body to fix these things. So that's pretty cool, right? It's pretty powerful. It's pretty amazing. Frankly, it's pretty godly. It's wonderful. I mean, it's amazing. It's magical. And, you know, I wish I could give you guys kind of my eyeballs to see the world, because you would see it in that way. And it's this beautiful, elegant system of the way that we work. And again, it's just trying to, get the pharmacology and explain it to you guys, but it's wonderful. It's wonderful. And again, as we understand this, it'll lead to longer life. We'll be driving a lot better vehicle. So, and we need to be driving better vehicles. So let's talk a little bit about how our brains work. Sorry, I went down the rabbit hole there, went a little preachy and all that, but that happens. So serotonin is an important chemical and neurotransmitter in the human body. It is believed to help regulate mood, social behavior, appetite, digestion, sleep, memory, and sexual desire. Do we really do a lot more than that as humans? I mean, that's kind of everything. Okay, that's a lot, right? So that's pretty important regulatory point. So what about dopamine? What does dopamine do? Again, dopamine, I'll just read it, plays an important role in executive. By the way, before I read that, on any of these things, you'll see, and I don't know if you can see my cursor or not, but you'll see that the reference, so I always try to grab the reference. So in most everything that we do at New Pharma, again, if I'm not providing a reference, ask, because there'll be a scientific or some kind of reference that we're citing. Again, I could tell you all this stuff, but I'd rather find sources, put that information together, and tell you in a story with other references than citing my own references, so to speak. It's more powerful, I think, creates a more powerful message, but whatever, it's all in there. So again, dopamine, let's just read this. Inside the brain, dopamine plays important roles in executive functions, motor control, motivation, arousal, reinforcement, and reward, as well as lower level functions, including lactation, sexual gratification, and nausea. The dopaminergic cell groups and pathways make up the dopamine system, which is neuromodulatory. Neuromodulatory means it works like your endocannabinoid system. You have ligands, and you have they plug into neuroreceptor sites, so transmitters and receptors that do work, and it depends on what they are as to what kind of work that they do. So anyway, that's kind of interesting, right? It looks like serotonin potentially, and just the words used, is a little bit higher function, and dopamine is a little, lower and maybe more basic function. Another thing, I don't really have a slide on this, but well, let's go through endocannabinoids real quick. So again, I'll just read this. So how does our brain work, and how do endocannabinoids work in the brain? As cannabinoid CB1 receptors are localized in areas important to memory, for instance, the hippocampus and hypothalamus, computer in our vehicle, right? Motor, our motor skills through the basal ganglia, and mood, prefrontal cortex. It is not surprising that the endocannabinoid system is postulated to be involved in diseases in which these processes are dysfunctional. So again, I pulled this quote because I want you to understand, and again, we'll drive this home in other ways, that this endocannabinoid kind of sits above, and it's more basic even than our dopamine system and serotonin systems, but it's what is manipulating them at a higher level and kind of determining how they work, provided all of those systems have the necessary resources to work. So endocannabinoids, dopamine, and serotonin all play a very important role in mood and cognition, and not just mood and cognition, but you're also seeing our motor skills, the very basic things about kind of how we function as a vehicle. We're kind of talking about our engine, really, not energy wise, but as will of thought wise. So what happens? So real quick, let's talk about this, okay? So all mammals have an endocannabinoid system. For the most part, all mammals have a dopamine and serotonin system. How is a dog different neurologically than a human? Okay, so let's talk about that. And this isn't research. This is complete observation, but I want to use it to make a point. So a dog has an endocannabinoid system. He's clicking along. He needs the resources just like we do. So he needs his L-tryptophan and L-tyrosine. He's got dopamine and serotonin. But a dog lives his existence uber relaxed or fight or flight, right? Dog goes from nothing to 0 to 60 all the time. They go from basically calm and quiet in their system to complete fight or flight, right? And so they have to manage that process in their bodies. It's a little different than ours. So we certainly have fight or flight. That happens to us. It's looking like PTSD, things like that are a result of kind of over revving our fight or flight system. And it kind of sets your brain to a pattern, again, which can be reset, but that is looking like kind of what's happening. There's research to indicate that, you know, our brains can kind of get stuck in a serotonin dopamine loop. But anyway, fight or flight is kind of an interesting thing to look at when you're looking at brain function and how our brains work. But let's talk about serotonin again. And let's talk about a shortage of serotonin. So if we had a shortage of serotonin, what would our symptoms look like? Again, we're in our L-tryptophan and L-tyrosine box, right? But we would be depressed. We would be anxious. We would have panic attacks. We would have insomnia. We would have irritable bowel syndrome, PMS, fibromyalgia. We might have a tendency toward obesity. We might be obsessive and compulsive. We might have muscle pain, a lot of muscle pain. So again, when you're trying to solve problems of like pain, this is something that you have to consider, because we might have a really good endocannabinoid medicine that works at pain, but it might not be considering the serotonin depletion or shortage. And again, that's something that needs to be considered with resources, right? So again, if you present your body with all these resources, L-tryptophan, L-tyrosine, you won't really have a shortage of serotonin, provided you have resources in your endocannabinoid system. So again, migraine, headaches, and alcohol abuse, interestingly. So what could help your serotonin, you know, if you want to supplement with something, and again, there's probably better ways to do this because you're intervening kind of down in the umbrella, so to speak. But you can take tryptophan, and tryptophan will absolutely help you build serotonin. You can take 5-HTP. Now, I would warn you against taking 5-HTP. A lot of people think that they'll get a mood lift or, you know, a mood, basically elevated mood from taking serotonin. So again, oh, if I increase my serotonin, that'll make me feel good and my mood will increase. Kind of right. Certainly you have the ability to be in a better mood because you have more resources. So, you know, you might also have more of an ability to be depressed, frankly, but you have more ability to run your mood with these resources. So tryptophan is the natural way that we get this. And tryptophan is in most meat, eggs, you know, things like that have protein. So most protein fat sources will have a lot of tryptophan. So you generally we're getting enough, but it kind of depends on your meat source. And certainly if you're a vegan, you need to pay attention to this. But I would caution you with 5-HTP as a supplement. Your stomach does something really cool. So if your stomach is in distress, the way that it signals your body is that it will release serotonin. It will overexpress serotonin, and it causes your stomach to cramp. So again, if you're vomiting or you've eaten something that your tummy doesn't like, the way that you're going to get rid of it is your tummy's going to overexpress serotonin. That's going to cause you to cramp and throw up or poop or whatever, right? You don't want to get too graphic, but that's what serotonin does in your gut. And your brain does something different. if your body understands it has enough serotonin and you take 5-HTP as a supplement, you will not have a good few hours. Your mood might increase a little bit, but your tummy distress will definitely increase, and it will not be a fun experience. And I know because I've done it, right? So most of this stuff, again, my wife and I try most of this stuff. We try most of our theories and, you know, the things that we're trying to do. And it's uncomfortable. But again, you can see some of the ways that you can supplement with things to increase your serotonin. St. John's wort, again, I would be careful with that. I would say the one herb that the FDA is kind of right in cautioning people about is St. John's wort. You can take too much of it. Just be careful, you know, with that. So tryptophan would be the best way, and that's the way that your body really wants to take in and break down, you know, serotonin. So do endocannabinoids regulate serotonin? So I pulled a study here. You know, again, you guys can pull the studies you want at NIH.gov, endocannabinoid serotonin regulation. You're probably going to get a bunch of studies, but I just kind of pulled the main one. And I picked through this study just to kind of pick and choose. And these are words from the study, not necessarily my words, but I would agree with all these words. But endocannabinoids modulate the strength of the glutamate synapses in the dorsal raphe via CB1 receptor. So the dorsal raphe is where serotonin is manufactured in your brain. So again, how much that is stimulated is a direct endocannabinoid response through the CB1 receptor. Your dorsal raphe, again, serotonin neurons, release endocannabinoids on demand. So when they're cued, not only are they releasing serotonin, they're also releasing endocannabinoids when they're cued. The release of endocannabinoids from serotonin fine-tunes synaptic transmissions in the dorsal raphe. So, and I may be saying that word wrong, you know, I'm not a PhD, forgive me, but I'm trying to explain advanced pharmacology. But the release of endocannabinoids from serotonin, again, fine-tunes synaptic transmission. Your endocannabinoids are tuning the way that your brain works. Okay? Pretty cool. The crosstalk between endocannabinoids and serotonin system regulates stress responses. Wow. Are endocannabinoids important? Well, is serotonin important? So holy cow. So again, hopefully you can see serotonin really important. If you don't have serotonin, you're going to suffer. You're going to break. Where does serotonin come from? L-tryptophan, or tryptophan. And again, can you supplement to add more serotonin? Yes. But you're better served really kind of working higher up. So again, when we understand all these little things that we need, like tryptophan and tyrosine and, you know, the omega-3 and omega-6 fatty acids is really what we need. So again, if you're supplementing with omega-3 fatty acids, something that's an alpha linoleic acid, you're really helping your body with dopamine and serotonin shortages because you're providing higher level molecules and you're letting your body do the work, which it kind of needs to do the work to break those down. Okay, well, what happens if you have a shortage of dopamine? Again, this should be a little lower level, you know, in my mind, so a little bit, you know, lower brain function, I would say, more basic brain function, like how you work your muscles. So, you know, muscle cramps, spasms or tremors, aches and pains, stiffness in muscles. And you can kind of go down the list here, but it's interesting, the mood, right? Low self-esteem, guilt-ridden, anxious. Those aren't happy words. So dopamine seems to be pretty important in how we run our, you know, mood and cognition, as is serotonin. But again, look at this another way. I come in and I present with low self-esteem, hopeless, big mood swings. I'm guilt-ridden and I'm anxious. And I come to you, doc, psychologist. You're going to say I'm broken, probably. You're going to prescribe me some kind of horrible SSRI inhibitor. And I just may have a shortage of dopamine. I just need a resource. I'm just dysregulated, doc. I'm driving a hoopty. Doc's got to get up to speed here, man. It's important. Okay, so again, let's say you do have a shortage of dopamine. How do you offset this? And again, a lot of it, phenylalanine, there we go. I want to say phenolphthalein, and that's wrong, but phenylalanine is where tyrosine comes from. And again, it's in a lot of protein sources. So if you eat protein, you're probably really not in danger of not getting enough dopamine, but it's how that dopamine is really regulated inside of you. And that kind of goes to the next slide. So again, this is from a study. You can pull this study, nih.gov. I'm just going to read you some statements from this study because I think they're important. And I apologize for reading to you guys. You guys can go pull this up on your own, but I just want to make the points, and I want to make the points really, like I said, using someone else's study. So the dopamine molecule is a major CNS neurotransmitter that has been the focus of extensive study due to prominent involvement in core behavioral processes, including motor control, motivation, learning, and memory, and contribution to several neuropsychiatric disorders, including Parkinson's disease, schizophrenia, and drug addiction. Wow, it's damn important, okay? Dopamine influences behavioral output by modulating basal ganglia circuit function, motor skills, basal ganglia, how we run our body, important. This occurs in large part through actions in the striatum, part of our brain, the primary input nucleus of the basal ganglia, how we run our motor functions, and predominant afferent target of midbrain dopamine cell bodies. That's a whole lot of words that basically means it's important in our brain. Research into mesostriatal DA circuits has revealed a crucial regulatory role for the endocannabinoid system, a vast signaling network that controls synaptic transmission through the brain and periphery. And in the paper, it does have a brief primer on the endocannabinoid system. Pull the paper if you'd like. It's kind of cool. So, and again, I'm just going to keep reading this because it gets better and better. So notably, many behaviors and disease states that have traditionally been conceptualized as dopamine dependent are now understood to arise from interactions between the endocannabinoid system and the dopaminergic systems, including motor control and motor disorders. Seizures, anybody? Okay, is this important? Yes. Reward seeking, addiction. You eat by reward seeking behavior. Pretty basic to our core, right? So this dopamine is a very important lower level neurotransmitter in our brain that controls and regulates motor functions, mood, energy levels, sex, feeding behaviors. Pretty important. All right, regulation of dopamine neurotransmission by endocannabinoids arises through modulation of dopamine neuron effector sites in the striatum brain. Endocannabinoid control of the striatal function. Again, it's looking like the endocannabinoid system controls that part of the brain. Dopamine neuronal activity at midbrain cell bodies, and dopamine release at axon terminal endings. So again, in all of these functions, when you're firing your dopamine neurons, there's endocannabinoids associated with all of that. And again, you developed an endocannabinoid system before you developed the dopamine system. It's more important, you know, as far as where it fell and how we develop things. So that would indicate it sits above dopamine. Okay, recent work is indicating additional mechanisms by which the endocannabinoid system signaling controls dopaminergic function, suggests that these two systems are even more unified than previously thought. And again, in the brain, this is the case. You don't have these systems tightly married in your skin, but you certainly have endocannabinoid all over your skin because it's regulating your skin too. So what I'm telling you, again, all these basic motor functions, and if you look at disease states that are mood, energy, body control, seizures, things like that, autism, this is a pretty rich place to look, I would say. While several questions remain regarding the precise location and mechanisms by which endocannabinoids and dopamine neurons communicate, it is clear that an understanding of dopamine neurotransmission cannot be fully realized independently of its relationship with endocannabinoid signaling, meaning that they're interwoven and tightly tied together. Okay, so pretty important. And again, I'm basically trying to present you with proof of what I'm saying, you know, as in my whole patter about the endocannabinoid system being our master regulatory. So let's talk a little bit about what's wrong with us, okay? So if you don't have dopamine or serotonin, again, you're going to break. You will present as depressed, as a Parkinson's patient, as having no motor control, you know, a list of symptoms that we just read through, right? If you don't have the resources to control inflammation in your gut, you'll present as obese. If you don't have resources to control pain management in your endocannabinoid system, you're going to hurt, okay? All of these things are endocannabinoid deficiencies. They're just deficiencies. And again, this has nothing to do with cannabis, guys. Nothing to do with cannabis. Cannabis has as much to do with the endocannabinoid system as morphine has to do with the endorphin system. So does it work to modulate it? Yes. Is it all it is? No, there's so many things that modulate it. So what we argue at New Pharma is that we need certain precursor molecules to be able to run our vehicle, to be able to drive that car of the future. And as we understand what these molecules are, we will be driving that car of the future. But right now we're not, because we don't understand this yet. We understand, we begin to understand it here, and we frankly may understand it better than most people in the world, but this isn't well understood yet. This isn't in the mainstream yet, but we're all suffering from an endocannabinoid deficiency. And again, am I the first one to coin this? No, Dr. Ethan Russo, when did he write this? 2004, was seeing things like this. So this is something that's common that a lot of us that are deep in this system are seeing, is that we all are suffering from malnutrition. And we're suffering from malnutrition in our master regulatory system. So that means we're going to break. And again, we're going to break predictably. Now, it also means that you can be fixed very easy. And I'm saying break, and again, I just said, went preachy at the first about breaking. It means that you can become dysregulated is a better way to say it, but you can become re-regulated as easily as you can become dysregulated. So as long as you haven't caused any permanent harm or damage to your body, again, most things that ail us can be addressed by re-regulating the endocannabinoid system in some way. And that's a damn powerful statement, friends. That's the future of medicine. That's the future of pharma. That's the future of education and medicine. That's the future of health. It's the future of nutrition. You know, we got to get over the whole letting endocannabinoid trigger us into cannabis somehow, because cannabis certainly is a way, but there's more to it than that. There's more to it than that. So if you guys have any questions, again, you can put them in your thread, and I think folks are watching. If not, then we'll kind of leave it here, but I'll give you a chance to ask questions, and I'll go ahead and shut down the sharing. Okay, and if we don't have any questions, then we will just leave it there. So thank you guys very much. Enjoyed it today. Hopefully you learned something. If not, we'll be back next week with something else new. So see you then. Bye-bye.